Hello class, today we are taking a look at our practice with one-step equations. So in each of these equations, these are our most basic type. We only need to do one thing to solve the equation. Let's start by our pictorial solution. We know that our equal sign is represented by our wall. Our x is represented by a long, skinny rectangle. And then we have -2 for our constant. So to draw a constant of -2, we draw two unshaded circles. On the other side of our wall, we've got -6 as a constant. So 1, 2, 3, 4, 5, 6 unshaded circles there. Now our goal in solving an equation is to get the x by itself. We talked in class about the idea of being annoyed in your room by your little brothers that are on the same side of your wall as you. And so those are the little brothers we want to get rid of. So how do we cancel two negative constants? Well, we're going to need to draw two positive constants since those will form zero pairs and cancel out. Now, just like anything in an equation, the equation means the same. So since I drew two positive constants on the left side, I also have to draw two positive constants to the right side. So I've done the same thing to both sides. To finish up, I want to know what the value of 1x is, and I can see that 1x by itself on the left side of the equation matches to four negative constants on the right side. So my solution is that 1x, or just x, is -4. In terms of the algebraic work to match that, we want to find our x, and we want to think about what is currently being done to it. So I can see that my x is being subtracted by 2, or minused by 2. In terms of my operation, I always want to ask myself, what is the opposite of that operation? So what is the opposite of subtracting 2? It's going to be to add 2. And just like with my picture, whatever I do to one side of the wall, I must do the same thing to the other side of the wall. So I'm adding 2 to both sides of the equation. Now what happens when I have -2 and +2? Well, those cancel out. The only thing I have left on that left side of the wall is an x. On the other side of the wall, we'll do our integer operation here. We were at -6, we've got less negative by 2, so we are now at -4. And of course, notice that we get the same solution, from both our picture and our algebra work, because it is in fact the same equation. Now to verify, these are pretty simple equations, but verify means that our solution should make the value on the right side, or RS of the equation, be equal or the same as the value on the left side. So the left side of the equation was whatever x is, subtract 2. I think the x is the number -4, so I'll substitute that in and check what the value of that left side is. -4 subtract 2 is like -4 plus -2, which is -6. The right side was -6, so indeed the left side is equal to the right side, and I've verified that my solution is correct. Remember, your solution should make the left side equal the right side, actually equal it. Let's take a look at the second question. We've got 3x's matches to 12 constants. So in this case, that coefficient is telling us that we have not 1, but 2, 3 x's. And remember, we like to stack those so our picture is most clear. So on the left side of the wall, we've got our 3 x's. On the right side, we've got 12 constants, and we want to sort those into our 3 rows with our x's. So we'll go ahead and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 constants on the right side, sorted into our 3 rows. Now that's great, but I don't care what 3x's matches to. I want to know what each x, or 1x, matches to. And I can see that this x matches to 4 positive constants on the other side. This x also matches to 4 positive constants, and the top x also matches to 4 positive constants. So each of my x's has a value of 4, and that's my solution, that x equals or is 4. In terms of my algebraic work, I want to take a look at my equation. That coefficient of 3 is currently multiplying the x. So I ask myself, what is the opposite of multiplying by 3? Well, it's dividing by 3. And just like always, what I do to the left side of the wall, I have to do to the right side of the wall. Now on the left side, 3 divided by 3 would be 1x, or just x. On the right side of the wall, we have 12 divided by 3, which is 4, so I can conclude that again, x equals 4. In terms of my verification, the equation was that 3 times whatever x is should be the value 12. I think that x is the number 4, so I'll substitute that in. And 3 times 4 gives me 12. The right side was 12, so indeed the left side is equal to the right side. Let's take a look at the next one. We'll start by drawing it. We'll start with our x, so we've got a single x in this equation, no coefficient. We've also got 2 negatives on that side of the equation. On the other side of the wall, we've got 4 positive constants. So we'll go ahead and put those in one row with our x's. Now, again, it doesn't matter where the x is, we want it to be by itself. So here's our x. What is currently on the same side of the wall is it? Well, it's these constants here. So how do we cancel out 2 negative constants? By drawing 2 positive constants to cancel out. If I draw 2 positive constants on the right side, I must also draw an additional 2 positive constants on the left side. Nothing cancels on the left side, which is fine. Finally, I can circle that I see that 1x is the same as 6 positive constants, so I can say my solution is that 6 is equal to x. In terms of my operation, I do need to be careful. When I look at my x, we are adding negative 2. So even though we're adding, we want to ask ourselves, like we did in our picture, what is going to cancel out minus 2? And of course, what cancels minus 2 is plus 2. So we'll go ahead and we'll add 2 to both sides. Now on the right side, minus 2 and plus 2 cancel out. We do still have our x on the right side of the equation. On the left side, 4 plus 2 is an easy calculation, and that's 6. Okay. In terms of my verification, the left side of the original equation was 4. The right side was negative 2 plus whatever x is. I think that x is 6, and negative 2 plus 6 has different signs, so we subtract the numbers. 6 take away 2 is 4. The bigger integer was 6, and it was positive. Is 4 equal to positive 4? Yes, it is. So indeed, the left side is equal to the right side. In the next question down, let's go ahead and start with our drawing. Now this x over 3 is a third of x. So if a whole rectangle would be a full x, we don't have a whole rectangle. We only have a third of it. So I'll go ahead. Here is an x split up into 3 parts. I only have one of those 3 parts. On the other side, I have 3 positive constants for my positive 3. Now, in order to solve the equation, I need to know the value of 1 full x. I currently have a third of x, and I know that I would need 3 thirds to make 1 whole. So I'm going to triple each side of the equation. Just to make it a bit easier to see the idea of 3 thirds making 1 whole, I'll draw that third in the middle. And I'll draw this third at the end. But I'm tripling the equation, so I have 3 thirds to make 1 whole x. Obviously, if we put these sections on top of each other, that one would fill in there, this one would fill in there, and we would in fact make 1 full x. Now, since I tripled the right side of the equation, I also have to make 3 groups of the left side of the equation, and each of those groups had 3 constants in it, so we'll put 3 constants in each of our 3 groups. To finish up, I want to think about what would make 1 full x. I would need all 3 of these guys to make 1 full x, which means I need all 3 of these rows on the other side. I can see that a total of 9 is equal to 1 full x. In terms of my operation, here's my x. That fraction, remember, is meaning divided by 3. So I want to ask myself, what is the opposite of dividing by 3? And the opposite of dividing by 3 is multiplying by 3. And remember, we use our dot symbol in algebra for multiplication, just so we don't get confused with the variable x. Now, as always, what I do to the right side, I have to do the left side, so I'll also multiply the left side by 3. 3 times 3 makes 9, and x divided by 3 and times 3 is just x. Obviously, divide by 3 and times 3 are opposites, so they cancel out. For verification, the left side of the original equation was 3. The right side was whatever x is divided by 3. We think that x is the number 9. We want to divide that by 3. 9 divided by 3 is just 3, and the left side was 3. So indeed, again, the left side is equal to the right side. Let's take a look at this one here. Again, it doesn't matter where your x is. So we've got 15 is equal to 3x. Let's start with 3 full x's. Perfectly drawn to be equal size, of course. And on the other side, we need a total of 15 constants. So we'll draw those in our 3 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I don't care what 3x's matches to, I want 1 full x, and I can see that each of my full x's is worth 5 positive constants on the other side. Bottom one is, this middle one matches to 5, and this top one matches to 5 as well. In terms of my algebraic work, the 3 is currently multiplying by the x. The opposite of multiplying is to divide by 3, and of course we'll do that to both the left side and the right side of the wall. On the right side, 3 divided by 3 cancels out, leaving us with just x. On the left side, 15 divided by 3 is 5. Of course, we get our same solution there as we did in the picture. For our verification, our left side was 15. Our right side was 3 times whatever x is. We think that x is the number 5, and 3 times 5 is in fact 15. 15 does equal 15, so the left side indeed equals the right side. Finishing up, we've got the equation that negative 8 is equal to 2 plus x. I'm going to start by drawing my positive x. I also have 2 positive constants on that side. They're not negative 2, obviously. On the other side, I've got 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8 there. To solve this equation, I want to get my x by itself. Currently, that x is being bothered by these positive constants. To cancel out 2 positive constants, I'm going to need to draw 2 negative constants to form those 0 pairs. If I draw 2 negative constants on the right side, I must also draw 2 negative constants on the left side to keep things fair. Finishing up, I can see my 1x on the right side matches to a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives. So I can say that negative 10 is equal to x. Taking a look at my algebra work, I want to think about what is going to cancel out the positive 2 that is being added to x. So what's the opposite of plus 2? Well, obviously it is minus 2. So I use orange to match my work over there. And if I subtract 2 from the right side, I have to subtract 2 from the left side as well. Now, plus 2 and minus 2 cancels out on the right side, leaving us with just our x. On the left side, we're at negative 8. We're getting more negative by 2, so that gives us our negative 10. In terms of our verification, let's go ahead and write out our original equation. The original left side was negative 8. The original right side was 2 plus whatever x is. We think that x is the number negative 10. 2 plus negative 10 has different signs, so we'll subtract our numbers. 10 take away 2 is 8. And the bigger integer was negative, so negative 8 is our solution. The left side was negative 8, and in fact, negative 8 is the same as negative 8, so indeed the left side is equal to the right side. So I hope that's helped you with your single-step equations for drawing pictorially, doing the symbolic work, and also verifying your solution.